ladies and gentlemen, to today's tutorial. Today we want to look at what we call glandular epithelium, which are specialized for secretion. We're already seeing the lining epithelial tissues, which are going to line, outer surfaces, as well as inner ventral body cavities, as well as the orifices. Today we want to look at glandular epithelium. Now, these glandular epithelium developmentally came actually from lining epithelial tissues, which grew downwards towards the connective tissue area, because we said that beneath every epithelial tissue there will be an underlying connective tissue. So once they grew towards where the epithelial lining is, then we are going to form what we call glands. Now, if there is still a connection between the surface epithelium and these cells, which are going to form the secretory material, then what happens is that we call it exocrine gland. But if there is no connection, if it loses connection, these secretory cells lose connection with the surface epithelium, then we are going to form this ductless gland known as endocrine gland. So for exocrine gland, the duct will be there, which is serving as connection between the distal portion, of that is secretory unit and the surface epithelium. But if there is no duct, then it's going to form this ductless gland known as endocrine gland. And this endocrine, because it's not going to have any transport medium, then there will be a lot of blood vessels developing around this area, so that the materials that will be secreted here will diffuse into them. And that is what we mean by endocrine gland. So there are two main groups of glands: either the ductless gland, which is endocrine gland, or the ducts endowed gland known as what we call exocrine gland. Now, mainly these glands are going to secrete, but of course, even apart from this, one thing that you have to know is that we could also have what we call paracrine gland. Yes, if it's a paracrine, then the cell will just make products, and then it will affect neighboring cell. It could also be autocrine. The same cell, the product it makes affects itself. Now, whether being endocrine or exocrine gland, what happens is that you may have two groups. You may be either unicellular or multicellular gland. Before I move more into this, I want us to go through the classical exocrine gland, that's the multicellular exocrine gland classification. We're going to look at that one. Now, mainly, we've seen that because the connective tissue is moved toward the connective tissue area, then when we talk about a gland will generally consists of three main components. It is going to have what we call a duct. It is going to have, let me start with the secretory units. It is going to have a duct system. Then, of course, it is also going to have connective tissue. Now let's see something. Now the secretory units of these cells, the secretory units can either be made of what we call serous secretory units, or they could be mucous secretory, depending on the nature of the product. Now, if it is serous secretory units, now let's look at the secretory units. If it is serous secretory units, assuming we have this, and then there's, let's say, mucous secretory units, then what we see is that the serous secretory unit is going to have triangular pyramidal shaped cells. These are triangular pyramidal shaped cells, and they are going to have rounded nuclei, which are somewhat placed, getting to the base cell placed. Now, these serous secretory are going to make serous products, which are rich in enzymes, and enzymes are protein in nature. Therefore, these cells will be endowed with a lot of rough endoplasmic reticulum, a lot of rough and smooth endoplasmic reticulum at the basal aspect, below where the nuclear, infranuclear position. And then apical to the nucleus will be granules. Granules actually for storing these proteins that will be made, and that is known as zymogen granules. zymogen granules. And we said we have rough endoplasmic column, yes, as well as free ribosomes. Now, what happens is that, yes, this rough endoplasmic column and free ribosomes actually convert this basal area to be basophilic, to stain with actually hematoxylin. So the basal area will be, basophilic. But apically, the zymogen granules will actually stain with eosin. So this place will be eosinophilic. Of course, the nucleus is going to be basophilic. Now, what we find is that, yes, the lumen is actually also smaller, relatively smaller, and that is what we mean by this serous secretory unit. So this serous is sinus. Serous is sinus. Plural is asinus. Now, for mucous secretory units, the cells are generally, columnar in shape. But well, some of them will also be triangular pyramidal in shape. Now, what happens is that they generally have a larger lumen. Well, what's the reason? The reason is that these ones, they tend to stain pale. And so when they stain pale, it appears that there's large lumen compared to this one, which picks up the stain intensity. Now, what we find is that they have rather apically placed, actually flattened nuclei. Surprisingly, they have what we call flattened nuclei. Yes, we know columnar cells are going to have columnar shaped nuclei, but actually they are having squamous flattened nuclei. And I'll try and explain it pretty soon. And apically, they are going to have granules, okay, represent actually mucinogen granules, mucinogen granules. Mucinogen granules will be stored here. And that is actually, the difference that we are going to find in the case. And these, the product that they will make, they are actually viscous. But this one will make watery, product. So this is the secretory unit of cells. But there could be another situation where you may have a secretory unit where it's actually mixed, having both mucous and serous secretory cell. So I will have the columnar as well as, of course, these triangular pyramidal shaped cells. I'll have, of course, the columnar, these ones. Now, what happens that during tissue preparation, we said that these columnar shaped cells will have zymogen granules, which are filled with mucinous substances. Therefore, they attract water because mucus is formed from water plus mucin, so that we form mucus. So they are highly, attracted to water. So the water over here. And then, of course, these ones are going to represent, yes. But generally, what I mean is that, yes, you may have a base gland this way, yes, with their nuclei. So, of course, these nuclei will actually be columnar. Initially, they could be columnar. Then you have a rounded nuclei, as well, having those granules, of course, the rough endoplasmic column and all that. Now, during tissue preparation, what happens is that the cells, these zymogen granules, begin to take in more water. When they take in more water, they swell and they're going a process known as mucinogen swelling. So when mucinogen swelling occurs in these columnar shaped cells, which are the mucous secretory cells, then what happens is that they begin to push inferiorly the nuclei. They will push the nuclei, they will push it inferiorly, and at the end of the day, what happens is that we are going to have the cells, the columnar shaped cells, yes, these columnar shaped cells will have their nuclei pushed down, so they assume this flattened nature of nuclei. When that happens, yes, these foreign cells, which are the serous cells, will also be pushed peripherally so that they form a cap of cells. And this cap of cells is known as serous demilum. Serous demilum. So if you have a cell, yes, this one will stain pale because exclusively you are having these columnar cells with these flattened nuclei, pale stained. But you have a cap of cells because it's actually a mixed cell, secretory cell units, and having this cap of serous cells. And this is known as serous demilune. Serous demilune. It's actually a mixed gland. So this with respect to the secretory units. Now let's look at the duct system. So remember that the secretory unit is actually going to make the secretory products only. So let's look at the duct system. Well, so let's look at the duct system of glandular epithelial tissues. We are actually looking at the compound glands, as well as the exocrine glands are concerned. Now let's look at this. If I have this, let's say this is secretory unit. And if this is the secretory unit, now what happens that for the secretion to come out, there are some, so there will be this basal lamina or basement membrane here, and in between this one there are going to be some cells which are actually epithelial in origin. These cells are known as basket cells or myoepithelial cells. And these myoepithelial, the word myo has muscle property, contractile, because of the process what you call actin. So when it contracts, then it causes the secretory materials to come out of these secretory units. And then when they come out, they meet the first system of channels known as these ducts. And the first duct that we meet, it's actually having short cuboidal cells or cuboidal. So this first group of cells that you find lining this duct, they are short cuboidal, forming this duct known as intercalated duct. Now this intercalated duct can actually also be lined by what you call these myoepithelial cells. May also line it. They can also be lined by these myoepithelial cells. So this actually forms the beginning of this duct system for most of these exocrine glands, except in the case of pancreas, where the central sinus cells, which later we get to know, actually form the beginning of the duct system. So this is the having cuboidal cells and all that. Now, the next duct that we find is actually having, could be columnar or could also be cuboidal, but generally columnar. Then nuclei, nuclei being a bit basally placed. But in addition, when I take just one of these cells, then what we find is that there is basal folding of the plasma membrane of these cells. Basal folding, and lying within them are actually these cells, these organelles known as mitochondria. So these basal foldings, as well as these mitochondria, give it a striated appearance. Therefore, we call this duct striated duct. Striated duct. So under light microscope, if you are seeing ducts like this having this striation, that's striated duct. Now, what we find is that these two ducts actually constitute what we call intralobular duct. because it's within the lobule of a gland, intralobular duct, Now, what we find is that yes, this intercalated duct, apart from serving as conduit for passage of these secretory material, it also modifies the secretory material. So it's a modifier as well. Now, what it does is that it has carbonic anhydrase activity. Therefore, it secretes carbonic, CO3 minus ACO3 bicarbonate ions into the solution and reabsorbs chloride ions. Then when it gets here, the striated, because of high degree of mitochondria, going to generate a lot of energy. And what happens is that it has what we call sodium potassium ATPase activity. What happens is it's also able to modify the secretion. It takes away what you call reabsorbs sodium and then secretes into the solution potassium ions. Therefore, we call the intercalated duct, because it has to do with anion, called the anion duct, and then the striated duct, the cation duct. So that is the dynamics that we have to understand. Now, as we move on, these ones, we are going to have what we call interlobular. So from intralobular, which actually consists of intercalated duct and striated duct, you go to the next one known as interlobular. Then you actually go to the next one known as lobar duct. Then you go to what we call the primary or the main duct. Generally, as you move on, then the stratification begins to increase. So generally, you may be seeing, something like pseudostratified columna. You may see stratified columna to stratified columna over here. So let's say stratified columna, or it could also be pseudostratified columna. Yes, you may be seeing these things actually over here. So when you are having these ones, then of course we are going to have this stratified. So as you move on, getting the larger ducts, then the number of stratification begins to increase. Now, generally, when you take some of these, salivary glands, for instance, if you look at the main ducts, for the submandibular, gland, then that one is going to be the Wharton's duct. When you take the parotid, Stenson's duct, for instance. Now, if you take, for instance, the main pancreatic duct for, the pancreas, the duct of Wilson, the accessory one would be Santorini, these ones, which later we get to see them. So that's the main duct. And the main duct, because we will receive a lot of them, it has to be stratified. So that is the duct system. Of course, the connective tissue is going to help in stabilizing it, serving as gluing material. Yeah, apart from that nourishment, we'll have to go through it, taking materials, waste and all that. We'll have to go through that. So this is the duct system. This is how generally, these epithelial tissues, which are forming glands, are going to be organized. But we said that if those ones which are, endocrine, they are not going to have this duct system only. They are not going to have it. Exocrine glands are going to have this duct system. But if you are exocrine and you are cellular, you are not going to have this duct system. You are just going to have, something like this. This cell, which appears like wine glass, having all these mucinous granules over here, having its nuclei around here. Then this cell is, having this shape of goblet shape, like wine glass. We call it goblet cell, and it's specially designed for secretion. Mucus. All right. So now let's look at the general classification of these glands, and we will end it.
Okay.
So this is the classification of these glands that we are learning actually. Now we said that glands may have ducts or may not have ducts. So if you are having ducts, you are exocrine. If you lack ducts, you are endocrine. Now whether or not you are endocrine or exocrine, you could be unicellular or multicellular. So for the unicellular exocrine gland, the well-placed one is the goblet cell, which we said is going to secrete mucus. Yes. And then for the unicellular endocrine gland, we talk about endocrine. Endocrine cells. These cells are going to make some hormone-like substances which are going to affect, the gastrointestinal system, contract. So that is these unicellular ones. For multicellular endocrine glands, yes, you have several of them. The pineal gland, the parathyroid, and what type of thyroid. the master gland, the pituitary, talking about the pancreas, islet of Langerhans and what have you. But the nature of arrangement, yes, they could be arranged in follicles, yes, in cores, yes. All these are some of the arrangement which the endocrine ones. Well, when we look at the endocrine system, we look at the histology. Now, for exocrine, which is the most important, because yes, the multicellular ones, they could actually be simple or compound. If it's simple, then what happens is that you have the ducts, and you are going to have the secretory units. It means the duct is not branching. The duct which is going to convey the product is not branching. Therefore, it's simple. Well, it could also be this way. Let's say these are actually secretory units. Yes, it's still simple because the duct, the main duct, is not branching, so it's actually simple. Then it could be, compound. When it is compound, then we are saying that the duct is actually branching, giving off some branching. Okay, something like this. So that's compound. So depending on it, if the duct is not branching, we say it's simple. If it's branching, we say it is compound. We look at the real-time sections of these ones to get better appreciation. Now, if it is simple, then we have to look at the nature of the secretory units. What is the shape of the secretory units? Is it going to have this sac-like appearance, or is it going to have this, columnar shaped, which we call tubular shaped appearance? If it's tubular shaped appearance, then we say it's tubular. But if it's sac-like, this way we say it's alveolar or acinar. So these are the situations. You have to look at the nature of the secretory units. Whether being simple or being compound, you have to look at the nature of the secretory units. Now, if it is simple, branch alveolar, simple branch alveolar, then the typical example that we have is the sebaceous gland. The sebaceous gland. Sebaceous glands, yes, some we have it in the tarsal, around the iris, and we call it the meibomian or tarsal glands, tarsal gland. Then for the unbranched alveolar, simple alveolar, usually we don't find it in human beings. Yes, it could represent the developmental stage of these glands. But for simple, branched tubular, the pyloric glands, of the stomach, are well placed in this regard. Yes, of course, sometimes you look at even the uterine tube, the uterus, its glands becomes so tortuous, can also resemble this one. Then for simple unbranched tubular, they are found in the the mucosal glands, yes, of these, small and large intestine, which we call them crypts of Lieberkühns. And then for simple called, they are going to find themselves, with the sweat glands, the sweat glands. Yes, for compound alveolar, we're going to find it in the mammary gland. Yes, apart from the mammary gland, yes, in the prostate gland is also going to find it there. These are some examples, but we look at the real histology of these ones. Then for compound tubular, we're going to look at the Brannus gland, typical example, and that's the submucosal gland of the duodenal gland proper. Then for compound tubular alveolar, the major salivary glands, the lingual, submandibular, parotid gland. Yes, even as part of the exocrine portion of the pancreas, we will have these kind of compound tubular alveolar structure. And we look at all these the histology of all these glands pretty soon. Now, but one thing that we have to know is that yes, the pancreas and then the parotid, they resemble, with the exception that pancreas is going to have endocrine portion known as islets of Langerhans. But apart from that, yes, they are also going to have all serosecretory units. We said that one. Said that serosecretory unit, you are going to find it in parotid. Yes, pancreas, the exocrine portion is also going to have serosecretory units exclusively. Sublingual is going to have majority of the cells have mucus, with just more, let's say 30% of it being what serous. Some are going to have actually 60% of its secretion unit to be serous. So these are some of the dynamics. But one thing that we have to tell here is that if the secretory unit is serous, the product will be watery, and therefore will have to require what we call modification. Therefore, serous secretory units, glands which are going to make a lot of serous secretory products, what happens is that they have well-developed intercalated ducts as well as striated ducts, because these ducts are going to modify the product. And so what happens is that yes, these ducts are going to have more. But if you have a cell which is going to produce more of mucus, then you are going to have underdeveloped intercalated duct, because at the end of the day it's going to serve as the conduit, but you don't have virtually absent striated ducts, which we have to understand. But in our later section, we get to see these in real-time sections. Now, the next thing which we are going to finalize with this tutorial is going to be the mode of secretion. And of course, there are just three, and that is what we have here. Based on mode of secretion, we are going to have what we call merocrine glands, or simply we call them ecrine glands. Okay. Then we also have what we call apocrine glands, and then of course we also have holocrine glands. So these are the three secretions that we have. And simply for merocrine glands, assuming this is a cell, and it's going to make products. Okay, so the product will be stored epically in vesicles here, and by way of exocytosis, they will be released to the exterior, and without loss of any other structure in the cytoplasm as well as apical portion of the cell membrane. When you have such a situation, that is merocrine secretion. In most of the secretions which are happening in the body, yes, it will go by this merocrine sort of secretion. It is hormones secreting and all that. Now, yes, and then even simple the sweat glands, which are we call them ecrine sweat glands or merocrine sweat glands. Now, for apocrine secretion, what happens is that yes, the product will be made apically stored in vesicles, but upon exocytosis, portion of the apical cell membrane will be lost, will form part of the secretory materials. And some of these, yes, we find them in the sebaceous gland, yes. Apart from that, even the mammary gland, yes, and we also have what we call, the apocrine sweat glands. But surprisingly, of late, what we find is that in books we are telling us that almost all these apocrine glands that were formerly classified are now known to be ecrine or merocrine glands. Now, for holocrine glands, sebaceous gland is not part of apocrine. For holocrine glands, what happens is that it's the cell actually undergoes a programmed cell death, yes, apoptosis, so that the entire cell becomes the secretion product, which is shared off, which it dies, and is seen mainly with the sebaceous gland. And it means that at every stage, if the cell wants to make food, it has to form new secretory units. So, ladies and gentlemen, this is actually an introductory bit, as well as far as these glandular epithelia is concerned. We look at the real-time sections in later sections of our discussion. Thank you very much for your audience.